Buddy. Hi. Let's start with the prayer. Father, Son, Holy Spirit. Hail Mary. Blessed are you amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners now and at the hour of our death. Amen. Father, Son, Holy Spirit. Amen. Great. Thanks. Today we're going to pick up where we left off. So looking at last time, we were in the midst of talking about this ambiguous case situation with these SSA triangles. Does that ring a bell to you guys? Yeah. Okay. We had talked about there basically being three situations depending on the size of that given angle. If that given angle was acute, you just have to make sure that the side opposite that given angle is the biggest side, because it has to be the hypotenuse. Has to be bigger than the other given side for a triangle to exist. If it is big, if that opposite side is the biggest one, there's one triangle and we're done. If it's not the biggest one, there's no triangles, you're done. The same thing is true if you have a 90-degree triangle. The tricky case is if you have an acute triangle, and the place where we need to be careful about is when the side opposite the given angle is the smaller side. In that case, we need to look at whether 0, 1, or 2 triangles is possible. I think last time I gave you this calculation in terms of like side BC and sine C and all that stuff. I'm just going to write it this way. It's really the longer side times sine of the given angle divided by the shorter side. It's the same thing, but like this to me is a lot easier to remember than a bunch of alphabet soup that's going to be labeled differently than the picture and then probably the problem that I've given or that I've been given. So I'd have to like relabel my given problem to match these letters, and it just kind of becomes a hassle. This to me is a little bit easier to remember. You guys agree with that? Maybe a little bit more practical. Now, this is assuming that I've already sorted out and found that I'm in, this situation where it's 0, 1, or 2, right? Okay. So let's run through a couple of examples with these in this SSA situation to make sure that we feel okay kind of working through all those details, because there's a lot of details there to sort through. Okay, so let's say we want to solve the triangle where angle P is 56 degrees, side P is 16 degrees, and angle Q is 19 degrees. So again, I'll start by drawing my triangle. I chose to give the third angle name angle R because, well, the alphabet. And then remember, I'm naming the sides opposite the angle with the same letter, just the lowercase version. So let's see, angle P is 56, side P is 16, and side Q is 19. So what situation am I in here? Side-side angle. Very good. So I know in the side-side angle I have to use the law of sines. But before I can do that, there's some analysis I have to do first to figure out exactly what I'm looking for. So the first thing I do is I look at that given angle. Is that given angle acute, right, or obtuse? Acute. And then if I look at the side opposite that given angle and I compare it to the other given side, is that relationship smaller, equal, or bigger? Smaller, right? The side opposite the given angle is smaller than the other given side. This was that troublesome situation where we can have 0, 1, or 2 triangles. Everybody's okay so far? To figure out which one of those 3 situations is going on, we're going to take the longer side, multiply it by sine of the given angle, and divide by the shorter side. As a reminder, real quick, when I type this stuff into my calculator, what do I have to be careful about? The mode, what mode should my calculator be in here? Degrees. How do I know degrees? The angles were in degrees, right? So I get 0.984. And the criteria here was if this number is less than 1, we get 2 triangles. If it was equal to exactly 1, there'd be 1 triangle. And if it was bigger than 1, there's no triangles. That was the criteria again. But here we have the 2 triangle situation. So as a teacher, one of the most common mistakes I see students have, or common problems I see students have when dealing with this particular situation, is just keeping track of all the information, right? So the first thing that I would encourage you to do is I'm going to make a place to kind of store all of my answers. So I'll make a little column for my answers from triangle 1 and my answers for triangle 2. Now, my angle P, my side P, and my side Q, those are all the same in both triangles. What's going to be different, though, are the values for angle Q, angle R, and side R. So to make sure that I can tell the difference between my answers, I'm going to label one as angle Q1, angle R1, and side R1, and then angle Q2, angle R2, and side R2. Just so that I'm able to keep straight my answers when I'm going and looking at things. This is me just trying to manage the information here. Is that okay with everybody? Okay. So in addition to making a place to record all my answers so it's nice and clear what I've done, I'm going to make a place to do my work for each of the triangles respectively so I don't accidentally use some information from triangle 1 in doing something in triangle 2. Does that feel okay? So I'm just going to make a little column, and I'm going to do all my work in triangle 1 on one side and all my work in triangle 2 on the other side. Typically, the way I like to do this, I like to do all of triangle 1 first, and then do all of triangle 2 second, rather than jumping back and forth between them. Although you could do that, I find that it's more likely for me to get confused and use the wrong information, the wrong context, if I do that, rather than just working straight through on one and then straight through on the other. But you can do whatever way you want. So for triangle 1, I'm just going to start this like my normal law of sines problem now. So I'm going to go look at my picture, and I'm going to look for the place where I know both the side and the angle. Well, that's P, right? I know angle P and side P. And then a situation where I know one of the other two. Well, that would be angle Q and side Q. So my law of sines that I'm going to write is sine P over P equals sine Q1 over Q. Everybody feel good here? Okay, we'll solve this just like we did last time. So I'll cross multiply. And then we'll divide by 16. And then how do I cancel out the sign in front of the Q1 there? Sine inverse, very good. So we'll do sine inverse to both sides. That cancels out the sign on the left. So we have sine inverse of 19 times sine 56 over 16. On the right, so I'll type that into my calculator. And I get 7989. So we'll go record that back in our spot. You'll notice here that I'm being pretty careful about labeling things with degrees. A lot of times I'm lax about that. In these problems, again, it's easy to get confused between angle measures and side lengths. So I try to make sure I'm doing a good job of putting my degree symbols on things so I don't accidentally think that 19 is 19 degrees or something. But again, that's your preference. I won't grade you down for doing that. I'm just pointing out things that I'm doing. Okay. So now we have to either solve for angle R or side R. One of them we can do right away. Angle R, right? And it's easy to do that because I know that I can just add up angle P and Q1 and then subtract those from 180. I don't need that. I guess I should do it. What am I doing? That is not what I want. Sorry. I forgot about the 56. I just subtracted the 79.89. I missed the 86 when I did it in my head. Whoops-a-daisy. Okay. At least I looked at it and went, wait a minute. That ain't right. Okay. And then the last piece then is to find that side R1, which is not a big deal since we have angle R1. We just use the law of sines again. So I'll do sine of P over P equals sine of R1 over R1. Everybody cool there? And we'll just solve, so we'll cross multiply. And then divide by sine 56. So type this into my calculator. And again, you'll notice that I'm using the fraction command like all the time when I'm doing this. Mostly I'm just doing this so I don't have to don't have to worry so much about using parentheses and to ensure my calculator is using the right order of operations. That fraction command is very nice in that it makes sure that your calculator is doing it the same way that it looks like it's on your sheet of paper. Okay. So this triangle 1 really wasn't any different than the previous examples we've done, right? Sure, I had to use an inverse sign here at some point, but like, big frickin' whoop. You know what I mean? So now there's supposed to be a second triangle here. I mean, if I got one piece, I could kind of get started or whatever. So how do I kind of get started in this? It's actually less work to do triangle 2 than it is to do triangle 1. And the reason is that finding this angle Q2 is really easy because it's just the supplement of angle Q1. Well, that's pretty nice. So now I have Q2 and P. So R2 is easy. Well, that's pretty nice. Pretty nice. And then, so the last thing I have to do is find R2. Here, though, I have to go back and use the law of sines to do that. So I'll do sine P over P equals sine of R2, which is now 2389 over R2. Everybody okay with what we did there? You notice that I'm using the ands command a lot when doing these problems just because it's less buttons to push than typing in all the decimals or whatever. And so I get 782 there. So let's go back and record that. I stopped doing that here. But I'll go back because people are probably still writing down the work. I want to point out to you the one place where students will frequently get stuck is they forget this. That to go from triangle to start triangle 2, we're just going to take the supplement of that first angle we found in triangle 1. That's the place where students, if they get stuck doing this, they'll get triangle 1 and be like, how do I start triangle 2 again? That's the part that they get stuck on. Now, it's easy to do. It's just a question of making sure that you remember it. You know what I mean? Nothing tricky about it, but it's one of those, it's like, it's not always entirely clear, like, why should that be the case? That's actually a rather difficult geometric argument to make that we're not going to take the, I don't know, probably the 15 minutes to really kind of give a thorough geometric explanation for it, because it's, well, it's not germane to trigonometry. It's like a geometry argument that if it was convenient, I would do it, but it's kind of a pain in the tuchus. Go away. All right. Let's do another example. So here we have angle A is 74 degrees, side A is 2.5, and side C is 4.9. So obviously one angle should be A, another angle should be C. I'm going to name the third angle B because, well, alphabet. So we have side A, side B, and side C, and then write in the givens. What situation are we in? Side-side angle. So we're going to be using the law of sines. But the side-side angle situation requires some extra checks to figure out what's going on. So the angle that we're given, is that acute, right, or obtuse? Okay. That's acute. So that's the one that requires the extra check. So if I compare the side opposite to the given angle with the other given side, is that opposite side smaller, equal, or bigger? So the side opposite the given angle is smaller. So that's the 0, 1, or 2 triangle situation. Okay. I see, Mr. Kulik. We're just going to do this a bunch of times today. So to figure out which one it is, I take the bigger side times sine of the given angle divided by the smaller side. And we'll go ahead and type this into our calculator. Oops. And I get 188, or thereabouts. The point of that, though, is that I really just care that it's greater than 1, because what does that mean? No triangles are possible, so there's nothing to solve for, so I'm done with this problem. Righteous, Mr. Kulik. Can they all be like that? Well, no. But if you do get a zero triangle situation, there's nothing more to do, right? If you're trying to solve for a triangle and no triangle exists, what do you expect? I ain't got nothing to tell you. I'm just going to show you that I know there's no triangle, you know? You guys feel okay on this SSA situation? Obviously, you guys will do some more practice in the homework or whatnot, but it's one of those that you just need to run through the steps a couple of times to make sure you're cool with all of that. Let's look at this situation. So we have angle A is 34 degrees, side B is 14 degrees, and side C is 17 degrees. So again, name my triangle. So add my labels, write in my given information. And what situation do we have here? Good, side angle side. So that tells me this is a law of cosine situation. Now, using law of cosines, there's only one piece of information that I have enough to solve for. That's going to be the missing side length. So a squared is equal to b squared plus c squared minus 2 times b times c times cosine angle A. And so right now I have a squared. What do I really want though? A. So what do I need to do? Yeah, we'll square root both sides. Notice that at no point in here am I going to like type these things into my calculator and get some intermediate number. I think it's just an opportunity to make an extra mistake or whatever, so I'm just going to kind of keep it all together and let the calculator do all the order of operations for me. I'm not going to try to outsmart the calculator or anything like that, because I know the calculator is real good at order of operations as long as I'm being real clear about the order I want it to do it. As long as it looks like what I got written on my sheet of paper, I'm usually good. So I get 951 there for that. Yes, sir. Of course. Now, to find angle B or angle C, I'm going to use the law of sines. I'm going to use the law of sines because the formula is quite a bit smaller. So do you think it matters which one I find next? I have enough information to do either one. Well, the answer is it doesn't matter unless you want to make sure your life is easy. I don't know about you guys. My life is hard enough, so I'm all about making my life easier as I possibly can. So to make my life easier, what I want to do is make sure I avoid that SSA situation, because that's what I'm going to be doing, where I can have 0, 1, or 2 triangles. The last thing I want to do is accidentally end up in a situation where it's a 2 triangle situation. I have to worry about getting 2 sets of answers that really one set doesn't even make sense given the other stuff going on in the picture, and it becomes really kind of confusing to sort through. This is the easy way of dealing with it, though. To avoid that side-side angle situation, we're just going to find the smaller angle next. But Mr. Kulik, I don't know angle B or angle C. How do I know which one is smaller? Look at the side opposite it, right? Which one is smaller between B and C? B, because side B is smaller than side C. So that's what we're going to be finding next. So we're going to do sine of angle A over side A equals sine of angle B over side B. So we'll cross multiply. And then how do I get the sine off of the B there? Sine inverse. So calculator time. So 5544 is what we get there. And now that we have angle B, angle C is easy, right? So 9056. That's not too bad, right? The thing to remember here when dealing with the law of sines is if I have the choice between solving for two angles, I always want to find the smaller one first. Okay? But again, if it's an always kind of rule like that, that's not too bad to remember. It's much harder dealing with like the side angle scenario where there's like a bunch of different things that can happen. That's way more confusing than a little example like that. We'll do one more example here today, and then that's all I need to do for today. So let's look at an example where we have side P is 5, side Q is 8, and side R is 10. So we'll draw and label our triangle. Everybody feel good there? What situation is this? Side, side, side. So what are we doing? Law of cosines. Okay. Remember though, the side, side, side was one of those that we put the little asterisk on because there's a little bit more to this one than meets the eye. So before we dive in and do the law of cosines, we need to check one thing. And we need to check to make sure this triangle is even possible. Because if I just give you three numbers, doesn't mean you can make a triangle out of side lengths of those three numbers, right? If I said 1, 1, and 100, if you think about that in your head, you're like, ain't no way I can connect those three sides to make a triangle. You know what I mean? Does anybody remember the check that we, to do that? Excellent. So leg plus leg has to be bigger than hypotenuse for the triangle to be possible. That's my check. It's really easy check to do, but we got to make sure that we remember to do it because, well, I'll guarantee you're going to see triangles here and there that are not possible. Okay? Note that it is a strict greater than. So for example, if I had P was 5, Q was 8, and R was 13, no triangle there. Okay? Leg plus leg must be strictly greater than hypotenuse. Greater than or equal to does not hack it. Everybody cool? So we're good here, right? 8 plus 5 is 13, and that's bigger than 10. Again, Mr. Kulik, how do I know which one was the hypotenuse? It's the biggest one, dude. I know it's like no doy, you thinking, but every year somebody asks, like, how do I know which one's the hypotenuse? And it's like, well, it's okay. All right. So now we have all three sides, so feasibly we could solve for angle P, Q, or R first. It shouldn't really matter unless you want to make your life easier, which I do. If you want to make your life as easy as possible and avoid any possible SSA situations in the future, we want to find the biggest angle first. So which one is that? Which one would be the biggest angle? R. We got some pirates in the back there, it sounds like. That was a joke, guys, because he said R. And pirates like to say R. So we say R squared is equal to P squared plus Q squared minus 2 times P times Q times cosine R. Now I want to point out to you guys the single biggest algebraic mistake I see students make is that they type in 5 squared plus 8 squared minus 2 times 5 times 8 to their calculator and turn that all into one number. Can I do that? No. The 2 times 5 times 8 is a coefficient on a variable. You can't combine that. My suggestion to you, don't do any combining. let's just solve this and move things around and not do any like simplification without the calculator. So I would start by subtracting 5 squared from both sides and then subtracting 8 squared from both sides. And then I would divide by that coefficient, the negative 2 times 5 times 8. Again, make sure you don't drop that negative sign. That happens rather commonly. Everybody still doing good? And then to get rid of that cosine, we use cosine inverse. And here's a situation where if you haven't been using the fraction command, boy howdy, you'd want to use it in this situation because you would need a bunch of extra parentheses to make sure your calculator does this in the order that you want it to. But if you use that fraction command, you don't have to worry about any extra parentheses, which is a pretty good deal in my book. Less buttons to push makes me a happy camper. So I get 90.90 or 97.90. Everybody cool here? Not a big deal. Now that I have one of the angles, I'm going to switch to using the law of sines. And which angle should I solve for? The smaller of the two. Exactly. Which in this case is P. So I will write, now that I know angle R and side R, I can write sine R over R equals sine P over P. And then I can just cross multiply. And then divide by 10. And then do the sine inverse to both sides. And then it is calculator time. So when I do that, I get 2969. And now that I got two of the three angles, that last angle is easy to get. So 5241. What do you guys think? Really not so bad, right? Algebraically, it's the same thing over and over and over again. You're just using these two formulas. The tricky part is making sure you're doing the things in the right order and using and like analyzing to figure out like what you need to do when. But the actual doing of the algebra part is pretty easy, right? It's just solving proportions and like, normal, pretty easy calculations. The tricky part is just making sure you're doing the right stuff at the right time. At this point, you guys should be able to do 1 through 22 and that for worksheet 1 should be doable. On Wednesday and Friday this week, we've done the first 3 sections of chapter 7 now. There's just 4 sections in chapter 7. So either Wednesday we're going to do section 7-4 and then take the homework quiz, or Friday we'll do the review stuff and take the homework quiz then. So the homework quiz will be either Wednesday or Friday. I would want to make sure that I've done a good portion of the homework before then so that I feel pretty confident that I know what to do in these different situations. For the homework quiz, don't worry about memorizing the formulas for law of sines or cosines. I would give you that. But knowing what to do when, I would expect you to kind of have memorized. So I'll give you the formulas for law of sines or law of cosines, but all the other details are on you guys. Does that feel okay? And then, needless to say, if we're reviewing on Friday, the test is going to be the next class day next week. I think that's Wednesday for you guys, since we have Mondays off. So the first day of class next week is Tuesday. Martin Luther King Day is Monday, so we're off on Monday. But all those dates are up in My Notre Dame, and the agenda for the week is on My Notre Dame. And I think all the stuff you need homework-wise is in OneNote. And we have, 40 minutes or so to 30 minutes, 40 minutes to get rocking and rolling on stuff. I would take a chance to get hustling on that homework so I can avoid having to do too much.